Okay. The next example. Now this is truly impossible with manual work in Rhino. This is where we'll make our own custom display mode for geometry. As you may know, it's possible to look at draft angles in Rhino. For example, you could have a torus and use the draft angle command to actually see the normal direction of these vectors here. So it's, let's see. And the way this works is it makes a mesh out of this shape. For every point in the mesh, it will actually calculate a color. And once you have a color per point, it can draw these gradients on the shape. And what we'll do now is generate our own mesh with colors. And we can actually combine multiple modes together if you want to. So this is not a texture, not an image. This is actually color on geometry directly. So that's what we have to duplicate here. And what we'll do is we'll start with a mesh object, a mesh plane. And for every point in this mesh, we'll measure the distance from it to some kind of object in the scene. So we extract all the points out of the mesh, giving us all these points. And for every one of these points, we'll measure the distance to this object here. So it's either nearby or it's far away. And then based on this distance, we'll create a gradient for nearby to far away and assign a gradient to every single mesh point, which should give us a properly visual feedback of proximity. So let's start a new file from scratch. I think I already have a, yes. So we have a file here in Rhino which has a bunch of objects defined in it. There is a mesh plane at the bottom, and there's two boxes here on the screen. The first one is quite simple. First step, it's the same as always. We create a new parameter, in this case a mesh parameter, and open the menu and we set one mesh. So we import this object into Grasshopper. I will also hide this object because we don't want to see it, and I will even hide this in Rhino itself. Those two things I will import using a geometry parameter, which is a parameter type which supports all kinds of geometry, points, curves, surfaces, meshes, breadths, and so on. And this time I will actually go in and set multiple geometries. So I will set not just one, but both of these objects will be selected and referenced inside this parameter. So in the tooltip you can see that it actually has two objects defined locally. Okay. Now I want to take this mesh apart into its loose points and loose faces. So I can actually sample the distance from every single point on the mesh. That is a component called decompose mesh, and it's the first component in the mesh tab. And it will actually take a single mesh object, and it will give you the vertices or the points on the mesh, which you can see here. Especially if I zoom in, you'll see that there's loose points there. It will give us mesh faces, so that there are quads at this time. Mesh colors, which don't exist at the moment because this mesh was just a mesh with no colors, and mesh normal vectors. So I know for every point in this mesh, the normal direction, and then it's a flat plane. All the normals point straight up, or 0, 0, 1 in this vector here. This is already good news. We have all the points here. So we just need to find for every point the distance to these pieces of geometry. We can use a pull point component for this. If you go to vector point panel, there's a closest point and a pull point component. And pull point has as a description to pull a point for a variety of geometry. So I can make it one of these components and actually project all the points in the mesh to our objects here. And to show you what just happened, I will hide these points and draw lines from the original points in the mesh to the projected points. This is interesting here. Here you can see that every point in the mesh actually projects onto the nearest object here. And if I move this object, you will see that there's now a new border between these two, where all the points on this side project to this block here, and all the points on this side project to that block over here. So you can see this thing updating in real time as we drag the object around. So let's put it back on the mesh here as an object and over here. Okay. So you actually see the border here between what's nearest to this box and what's nearest to this box. It's actually a pretty interesting line. It's not straight as you would expect. It's actually a slightly curved line. So I don't actually want to see these lines. They're nice to look at, but it's very busy. So I'll remove those. And instead of looking at the points, which also are not very informative, I will hide this component and only care about the distance output. So this component tells me where the point is after the projection and also how far away it was. So this distance here is a direct measure of distance between the point and this nearest object. It'll be somewhere between 0 if it's directly on the object and about, I suppose this distance is the maximum here, which is, if I measure that in Rhino, it's about 25 millimeters. So our distance gradient should go from 0 to about 25. So I can make a new gradient using the param special tab here. There is a color gradient component. And a gradient works by sampling this gradient along certain distances along the length of the gradient. And by default, it starts at 0 at the left here. So if it's 0, it's pink. And if it's 1, it's at this edge, it's purple. So if the distance is 0, it's pink. If it's 1 or larger, it'll be purple. Now our distances can go pretty big. They can go from 0 to 25. So you need to change the limit here. And I can do that by changing the L1 value from 1 to 25. And if we plug our distances into the T input now, we can have them evaluate along this gradient somewhere. So the last step here is to assign these colors back onto the mesh so we can actually see in space this gradient. There's a component in the Mesh tab which allows you to assign colors to an existing mesh, just called Mesh Colors. And by default, it has 8 predefined colors, and they're all kinds of green. So if we take this mesh and actually color it, we get those 8 colors assigned in sequence, and then it repeats the same colors over again. And these colors are things like dark green, forest green, yellow green, lime green. However, we have colors for every individual point here, so we can override the default colors and actually have a look at this mesh with the assigned colors to it. And to amplify the effect, I will pick a different gradient here. So I'll go to a gradient like this. So here you can see how the colors change from nearby to medium far away to really far away. And of course, as I change this gradient, those colors should shrink around that shape or bulge. So this is the green to yellow to red gradient for both objects. And it already allows us to generate this kind of nice visual feedback, which you otherwise wouldn't get. But it's actually quite cool. We can even combine multiple gradients in a single mesh. As you'll recall, we had 2 objects here, and we measure distance to both objects at the same time. What if I only select one object here? So if I override this list of geometries and only pick a single piece of geometry, we get one gradient for this block, and I'll make it simpler. I'll just go from green to black. By the green, there we are, green to black. And I will copy all of this. Actually, I just need to copy all of this. And this time I will evaluate the other box. So in here, we'll measure distances to the second box. And here we'll have a different color, say purple. I can replace these two, of course, and you can see the changing between one and the other one. But we can even combine them. For example, an addition component, it can add numbers, but it can also add colors together. So if we add these two colors, we can actually now have both colors at the same time. So it's the purple and the green actually cooperate to generate those two. And you can, of course, repeat this for as often as you want. But when you add colors, they do get brighter, so eventually you'll probably end up with a completely white image. I could also choose to subtract colors, so I don't know how it would exactly work, but if I use subtraction, then I'll probably get something pretty weird. Let's go to white. Yes, so subtraction actually makes stuff darker. So as this thing moves closer to, it should remove colors, but it's less obvious how this works. So Mary, are there any questions so far? No questions. That's amazing. How do you bake colors? That's a good one. Well, this mesh here actually has colors built in. So if we bake this mesh object, it should just generate a mesh with those colors on it. So that just works out of the box. And there's a number of export flavors like Vermel or I think even SketchUp, which support this stuff. But you can't render this because this is not a texture. This is a pervertex mesh color, and most renderers don't understand that kind of geometry. So baking works, but I wonder if it's useful downstream. Okay. So this is how we make a custom analysis mode. And of course, this doesn't have to be the same thing. It can be something very different. You could choose to examine distance in this gradient and elevation in this one, or maybe angle, or maybe curvature in this one, or, well, think of it as possible. Okay, the last example, I think.